I'd like to introduce our, what we should call our short talk speaker for the evening. It's Dr. Bernd Friedlander. He's a licensed chiropractor, has a bachelor's degree in physical education with emphasis in applied kinesiology from San Francisco State University, and a doctorate of chiropractic degree from Los Angeles College of Chiropractic. He's been involved in developing nutritional therapies since 1982. And as a result of his therapeutic formulas, he pioneered the research and use of nutrition and free-form amino acids for improving athletic performance as a safe alternative to steroids. During his career, Dr. Freelander has served as a nutritional and sports injury consultant for athletic members of the track teams at UCLA, USC Berkeley, Stanford, and many professional track and field athletes from all over the US. He has also worked with professional players from the Los Angeles Rams, Los Angeles Raiders, Los Angeles Clippers, and Los Angeles Lakers, and the San Diego Chargers.
I did?
Good, we got out of Los Angeles there, Friday, San Diego. In 1984, he served as a chiropractor and nutritional consultant to numerous members of the U.S. Olympic track and field teams and the U.S. Olympic crew teams. You also, did that say nutritional?
No, I was also selected as the coach and chiropractor for the U.S. Olympic in '84.
Yeah. So in the ensuing years, Dr. Friedlander has been developing a number of proprietary nutritional formulas. These formula products are designed to maintain and promote health and longevity. You've been working with the Florida A&M University College of Pharmacology, amongst others. I think that's all I'll say. Please welcome Dr. Friedlander.
How are you? Okay, let me have this. Hello, wake up, stand up. Get some breathing. Everybody get this, because I summarized everything I'm going to talk about, and it's all in this, so you'll understand. Going back into years, first in sports medicine, I was directly working in physical therapy and exercise physiology, then chiropractic. So my whole life was developed in sports and developing nutrition for the athletic performance area. And then I got into UCLA, where I became more involved in the athletics, U.S. Olympic, Raiders, Rams. And then I got into a very exciting area of caloric restriction diet and anti-aging. And in '81, I developed and got my sort of devotion and energy and drive to help my father overcome cancer. And it didn't work, and I started developing and researching cancer probably more than anybody in the world today. And because of that, I have taken on over 14,000 patients in the last 15, 20 years to consult on cancer and other diseases. And I'm currently working with Elizabeth Crabtree at UCSF, who's the world leading expert in neurology in MS and other conditions like that. And we're looking at approaches that we can take that are natural to help overcome MS. I've had over a dozen people completely recover from MS, not all of them, but most of them all recovered. There are certain issues or standards that you can't always help everybody because of stresses and lifestyle, and you have to change that, and you have to change the emotion. I'm currently working with Elizabeth Mazzio and Karam Solomon, who are, I think, one of the two top people I've ever met in the field of looking at medicinal compounds, over 20,000, that have anti-mitotic, anti-tumor mechanism, mitochondrial benefits, neurogenesis, and we'll talk a little bit about the research that's currently going on there today and some of the exciting areas. Like everybody, we all have an interest in how to obtain health, longevity. We're not going to reverse it unless we freeze ourselves. And I have a refrigerator that I will sell to you, and you can go in there and I'll open it up in 20, 25, 30 years, and hopefully you'll still be young. And we'll have discoveries. That's really what it is. But everybody says, you know, what we want to do is we want to live to 70, 80, 90 and not have arthritis, diabetes, cancer, heart disease. Really, that's really what we want to do. So if there's a magic pill that's going to extend your life to 120, 125, and you don't have the genes, forget about it. You have to have a couple different genes, the FOXO and several other genes, and then you can smoke, drink, and live to 90 to 100. Okay? And if you have that ancestral background, you're good to go. Don't try anything else. But what we want to do is look at how we can maintain our health. And there's ways that every disease is correlated to one thing, mitochondrial. It's the first DNA. It's the bacteria that billions of years ago that gave birth to everything that happens today, every living systems. And it's all research studied, and it's the number one thing right now in every institute today. Every institute. I talked to Linus Pauling at Oregon, Tori Hagen. I spoke with Ray Peat. I spoke with Gilbert Ling. I spoke with John McMichaels. These are immunologists, researchers from all over the world. Everything today in gerontology, from UCSF to USF to USC to Harvard, Sinclair, it's NAD, it's mitochondrial. That is what controls everything that goes on. It's the energy source of our cells. It's the organelle that gives us vitality and energy, immune function, repair and regeneration. Without the mitochondria, we can't do that. But very interesting, the mitochondria is involved in so many other areas. Like Tori Hagen right now is looking at the cell membrane of the mitochondria. And he's discovered that are ceramide peptides. These are inflammatory peptides, and they protect the barrier of the skin. So if you want to look 10, 20, 30 years younger, you have to have these ceramide barriers, okay? And that's C16. But in the nucleus or in the cytoplasm or the cell membrane of the mitochondria, there are other ceramides that are very important in maintaining the structure of the mitochondria and allowing energy and communication to occur, and that's called C24. That's a carbon. These are fatty acids that are so crucial in these in developing the right ceramides for anti-tumor mechanism or for skin and cell membrane and beauty. So that's an exciting area. But today we're going into a much greater area of mitochondria understanding. And once you understand this, everything can be resolved very easily, and it doesn't take a lot of money. For instance, I want you to look at what Dr. Elias has done with apheresis, which is removal of plasma. I've been looking at that for the last 10 years. There's a compound called GFD11. It's a molecule that helps to regrow tissue in our own body, and it comes from the plasma, but you have to clean the plasma and get it from a young plasma of a young individual and put it back into the body. That's where all the science is going today in Europe and all that, is cleaning the plasma and then finding the nutrients that are found in the plasma that can regenerate, and that's what they're doing today. Now, you can do the same thing without spending a lot of money, and I'll tell you how to do that. Go into George Askar, A-S-K-A-R, and just look up his research and his science. He is talking about cleaning the plasma to reverse arthritis, cancer, and diabetes, and all kinds of disease. And he's talking about cleaning the plasma. That's what it is. But we're going to do it simpler by changing and improving mitochondrial function. Okay? So, okay, an overrule, we know aging and every disease has a mechanism of inflammation. No doubt. We all need inflammation. It's part of our life. But too much inflammation causes diseases, aging, and we have arthritic, we have bone diseases, we lose hip, we lose cartilage. These are inflammatory mechanisms. And what they do is the cell, under such inflammatory mechanism, makes a change. And that change is what creates the problem and the havoc of all diseases. And that's what we're going to look at. So our cells, are predominantly the largest. We have more mitochondria than any other cells in our body, because otherwise we couldn't function. Okay? So it's important to understand that. So we're going to talk about how to improve mitochondrial function, how to increase the recycling of the junk out of our cells so that we have a healthier, younger mitochondria to function, and that's Anne-Marie Corbel's research out there. Anne-Marie Corbel, look her up. She's a brilliant scientist, all right? So we're going to look at what is aging. Aging is a decrease in metabolic function, really, in our rate. The energy and efficiency declines at the cellular level, and that's what it is. The organ, the organism, all of that. An increase in inflammation, and it's the prolonged inflammation. And we're going to talk about the key factors, how to reduce inflammation. It starts by decreasing protein renewal, and then you have mitochondria dysfunction. Is a primary cause of aging. It is linked to every single disease. It's now researched everywhere. So what happens is we have low levels of, and one of the key things in all diseases, we're identifying the principal factor. What it is, and even Frank Schallenberger talks about it, and so does Robert Rowan. There's a molecule that we all have called NAD. Every system in our in every living system, plants, animals, human beings, every system that breathes and lives, even plants, oxidation reduction, electron transport, electron acceptor, makes energy, ATP. The byproduct of ATP is CO2. And CO2 converts in our blood with the hemoglobin and picks up in exchange for iron. And iron brings the oxygen back into the cells and utilizes it for what? Oxidation, NAD. So that's important to understand, is this mechanism of CO2 is the byproduct of energy. And this is so crucial because in athletic performance, we all train athletes at high CO2 levels to increase CO2 levels, because that gives the mitochondria a more efficient oxidation process to make more energy. I was a member of the '68 Olympics as a runner, and I didn't participate because I only ran track 1 year. I was 100 and 200 meter. But when we went to Mexico City, the team did, I didn't, it was a high altitude. So I remember the athletes I worked with and I was training with were training in high altitude to get CO2 used to build up the CO2 in our blood. And that's so crucial today. So what happens under inflammation when it's constant? Oxygen levels are low, okay, under inflammation. And it's due to chemical, environmental, and physical and psychological stress. It's not just one stress, it's many stress. Like he says, one of the things I do a lot and I see a lot, and I'm treating somebody with cancer right now, and they're right next to an airport. Can you understand? I've been telling people who I've known for years, do not live next to an airport because lead is a very toxic component. And one of my patients was about 20 years ago, was a patent owner of drilling for oil. He worked with Chevron. And he came to me for cardiovascular disease. And one of the issues, and I was really understanding at that time what was happening, and the problem was he was involved in oil drilling. And so he was always involved in that field. And he was contaminating himself with high lead and other factors. And I asked him one day, because someone else told me this, the invention of the airplane was the starting point of all diseases today. That started the chaos of all planet, weather problems, and everything. He told me right before he passed away from a heart disease, he was living in Texas, so I wasn't able to see him all the time, that you're absolutely right. It was the discovery of the petrochemical industry that started the whole cascade of what's happening today in our environment. And planes are number one. I treat a lot of stewardess and pilots for a lot of different conditions. A lot of stewardess with breast cancer. A lot of pilots have seizures. They have because of the high altitude and radiation. So that's very common. I recently had a patient that I sent to Lensaputa about several years ago, and she had a massive breast cancer, and she was an airline stewardess, and she came to me from Gerson's clinic. Gerson asked me to look at her. I worked with her, and I said to her, finding out she's a stewardess, I said, until you stop flying, this will not work. She didn't want to stop flying because that was her financial way of getting her, food and paying for their home and supporting her kids. So it got 4 or 5 years later, we were able to suppress some of the cancer, but it just blew out. And then she realized she had to stop flying, so I had to go to Lensaputa to get disability and all that. And it was kind of late. You're still flying for 20 years. What's going to happen? And that's what happens. So that's an issue that we have today, is that get away from the environment that creates the problem. Otherwise, you cannot repair. So what happens is we have a lot of situations occurring. And some of the things is, again, we talk about the mitochondria as being a primitive DNA, and that started building blocks to everything. So you have to understand how important that is. Without the mitochondria, you and I wouldn't be here. And what happens is it's involved in oxidation. The key thing is oxidation is a major factor of oxidizing glucose. Okay? You have to understand that that's the normal process of the mitochondria. It takes electrons, transports it, and breaks it down and makes energy, and it's oxidation phosphorylation. When we are under a lot of stress or inflammation, what happens is the cell changes, the metabolic rate changes. In case of cancer, the cancer goes into a hypermetabolic state. And what it does, under low NAD levels, we have a molecule that is increased in order to help against low oxygen and low NAD, low oxidation glycation. And that is hypoxia-inducible factor 1. And this is one of the pathways that we're looking at today for virtually every disease, because it is one of the ways we are looking at blocking. And I'll go down here and show you what hypoxia-inducible factor does. And let me go back to here. And you have it in this outline. This is one of the areas I did some research in, was looking at the changes that occur. Okay? What happens, there are pathways called H1F1. Under low NAD levels, H1F1 reprograms the cells. It reverses the program of the mitochondria. It makes it run differently. So what happens is, instead of looking for sugar to oxidize for energy, it now goes into another mechanism called aerobic glycolysis. Okay? Aerobic glycolysis is a way that all cancer cells, diabetes, heart disease now function. Our cell becomes swollen, increased water retains itself, and it pulls in more sodium. And that swelling excitatory mechanism increases in our cells. All right? And that is a component of cancer and fibroblastic tissue. And that's why the only way we can measure cancer, if it's truly cancer, is MRI. Because MRI measures this T2 wave. It's a wave that is found in the cell that is based on the water molecule and how long it relaxes and how fast it recovers. So if the molecule goes like this and comes back quickly, there's no cancer. But if it's relaxed and takes a longer time, then you know there's a dysfunction in the cell. And that water molecule is one of the key factors because all cells are made out of water and proteins. It's called Cells and Gels, the Engine of Life. I want you to get that book, Cells and Gels, the Engine of Life. And that's Ray Peat, that's Gilbert Ling, and Raymond Damanium. Raymond Damanium is the inventor of the MRI and the phonar. And in 1970, he got a Nobel Award. I had 2.5 hours of conversation with him about this, about water retention, the molecule of water in the cells, and the protein, and what do they look like. And he said they look like gelatin. Our cells are identical to gelatin. That's why collagen and gelatin is very crucial, and that's why Linus Pauling was involved in vitamin C, lysine, and proline. What does lysine, vitamin C, and proline do? It's the precursor to collagen. And before he passed away, he mentioned how important collagen was to the arteries, to the cell membrane, to the bone, to the immune system. It's the structure that keeps the cells alive with water. It's the molecule of life. That's why Cells and Gels is important to read. It tells you about that. So what happens under stress, any physical stress, NAD levels go down. When we're born, we have a 700-to-1 ratio of NAD to NADH, which is the reduction state. 700-to-1 ratio. That is a normal, functioning, youthful cell. It starts declining. The levels of NAD starts declining as we age under influences from epigenetics, from faulty mechanisms, improper nutrition, stress, physical, environmental, chemical, heavy metals, radiation. All of these are factors that you know that some of the medications you get from your doctors causes mitochondrial dysfunction. And I'll show you all the medications that are proven in PDR and research to have mitochondrial dysfunction in medication. You can look at them. So what happens is we look at these molecule changes. So when NAD becomes low, and there were scientists today that have monitored this in cancer patients, that every single patient that has cancer has extremely low NAD levels. So the body goes into a reduction state, and that's what happens. So so under those conditions, NAD leads to hypoxia-inducible factor 1, which leads to aerobic glycolysis, which makes the cells use a different method for energy. And what it does, it goes after your protein anywhere in the body. It doesn't look for sugar anymore, so sugar has nothing to do. By suppressing sugar, you're doing the wrong thing. And every cancer patient that I see that comes in, and I'm working with the National Cancer Research Foundation. They're the only group that has proven to work in cancer research. And you'll see they're all on a Atkins type of diet. They're on a paleo diet. That's what they have the studies and the science, and you can look at it. Every patient, it has nothing to do with sugar. What happens? Why? They start losing weight, right? They lose muscle, fatigue, because the cells start breaking down our own protein called fatty acid synthesis. Fatty acid synthesis, FAS. Look it up and Google it. PubMed, you'll see over 100,000 publications on FAS right now as one of the top leading research in the area of blocking cancer cells. By inhibiting fatty acid synthesis, that's one of the main areas that we're looking at for all cancer. So what happens is the fatty acids are, the mitochondria now shifts to an aerobic glycolysis from pyruvate to lactate. And that mechanism breaks down our protein for fats. It looks for it oxidizes fat. That's how it survives. That's how it makes energy. That's how it makes the cancer grow and spread. And hypoxia-inducible factor is the beginning process to do that, and then fatty acids come in there, and the synthesis of fatty acid synthesis is a big factor, and it's all in this here. You can look it up. The other thing is when you have that happening, another pathway gets involved. mTOR is another pathway. everybody's looking at stopping aging by inhibiting mTOR pathway. Richard Miller, look up Richard Miller. He's an MD, PhD. He has a whole article, a scientific paper on mTOR and how to block that, how to inhibit that, because it causes faulty protein synthesis. It causes misfolding protein, which is glycation. It causes, it increases reduction state. It lowers thyroid function, all of that. And that's due to amino acids, tryptophan, methionine, and cysteine. Read about it. There's a lot of research on restriction of amino acid tryptophan, methionine, and cysteine, and how that affects inflammation, glycation, aerobic glycolysis, oxidative damage, kidney damage, liver damage, and thyroid dysfunction. This is the science. It's right there. As a matter of fact, when I was doing caloric restriction diet, I found that you can do the same thing by reducing these 3 amino acids and get the same results, identical results. And it's published in PubMed right now on all that. Another area that also changes immediately when you have hypoxia-inducible factor, fatty acid, mTOR, another pathway which is very crucial is IGF-1, insulin growth factor. Every scientific institute today are looking at how to reduce IGF-1, right? Because it can control diabetes, heart disease, and it's also linked to cancer. IGF-1 also raises when NAD levels are low in the mitochondria. It's all due by one mechanism, the nuclear factor of the mitochondria, NAD, nicotinic functions of the oxidation of the mitochondria. So the oxidation factor, if you go back through the 80s and 70s and 90s, you'll find that if you actually increase your oxidative state in the metabolic rate, you live longer. They've done clinical studies in animals, and then they've shown in humans that who live to 90 or 100, they have a very high oxidative state, meaning their NAD levels are high. That's why Frank likes to use, and Robert use, ozone therapy, because supposedly ozone significantly increases NAD levels. It does in some way by the oxidative state, and it can do that. So what happens is, when we get into, so we want to, all these communication patterns are disrupted now. Protein synthesis is disrupted, so cell communication is completely dysfunctioning. And so our cells are looking for a challenge. They need a challenge to repair themselves. And some of the things we can do to reverse that, I'll talk about in a few minutes. So today, in cancer research, and if you look at any research in cardiovascular disease, if we can only do one thing, is increase NAD. That has more merit than anything else out there. How many of you heard of the Calgary study that came out way back in the 80s, 90s, and it was on Charlie Rose, it was on Larry King, about DCA, dichloroacetate? How many have seen that? DCA is very powerful. It's one of the, you know that it was taken off the market here because it's one of the most effective treatments for cancer, okay? DCA, what it does, basically, it suppresses an enzyme in the mitochondria that causes that goes from pyruvate to lactic acid. The problem with lactic acid and part of the aerobic glycolysis, it forms free radicals. So now there's evidence and measurements that they've seen that in all cancer, diabetes, heart disease, Alzheimer's, Parkinson's, arthritis, and aging, a high level of free radical damage, ROS. And that is a byproduct of low NAD, high IGF-1, high fatty acid synthesis, mTOR, increased mTOR pathways, and IGF-1. Okay? These are all connected, these pathways. They control oxidation, reduction states. So all of these are linked to these high levels of, and they, by producing from pyruvate to ATP and CO2, they go to lactate. One of the problems with lactic acid is that in the inside of the cell, it becomes becomes a high pH. All cancer cells, according to Raymond Domanium and all his research since 1970, looking at MRI and looking at hundreds of thousands of patients, we have an increase in pH. People would think it'd be the opposite, right? No, it's increase in pH. The outside of the cell is highly acidic because of the lactic acid. What the problem is also, our natural killer cells that are ready to attack these cancer cells will not attack cancer cells because lactic acid interferes with natural killer cells and B cells. It actually inhibits their function. This is in literature. Look up lactic acid immunity in cells. It's available. There's also a multi-drug resistance factor that's found in all cancer cells, discovered by over 20 PhDs, and it has ability to regurgitate all chemicals, radiations, because a cancer cell is very intelligent. It wants to survive. It has an immortality. It has an unlimited telomeres. You know, those enzymes that are in the chromosome at the end of the strings that look like shoelaces. They have immortality. But they also have a chemical compound, a protein compound that regurgitates chemoradiation or anything. So it sends it to a normal cell which has no protective. And they also have a glycoprotein mechanism around the cell, which is a human choriogonotropic hormone, which is a stimulating pregnancy all the time in that cell. And look up Acevedo's work, Hernan Acevedos, Acevedos. Look at his 40,000 culture studies. He's a pathologist at the Philadelphia Cancer Clinic. He was given 40,000 cultures of cancer patients from literally every cancer institute to identify the common denominator, mitochondrial dysfunction and HCG, he said to me. And there is a vaccine for that, but you won't hear it or see it. So what happens is, you know, genes have a way to shut themselves down and go into a different method of energy. So we're going to look at these factors I just talked to you about reprogramming themselves and all that. So what do we do, okay? One is that in order to reverse disease, we want to look at a couple things, and I don't have enough time, but let me go into a very exciting area that we can really work on, even more than what I said here. One of the simplest molecules we can all take on a daily basis, 500 to 1,000 to 1,500 milligrams of niacinamide. Niacinamide and niacin are directly precursors to NAD. And if I have time, I'll share with you 5 patients that have recently, and she'll tell you she was there when she heard that they were in total remission with their cancer after 6, 10, 15 years. Is by giving certain nutrients that weren't more than maybe 5, 7 bottles. Another thing that helps with mitochondrial function is biotin, B1, B2. All the B complex are important. CoQ10, lipoic acid, very important. Not so much C and E. Wasn't shown to really have that effect on raising. PQQ is a biogenesis. It only helps mitochondria, but has nothing to do with really NAD levels. There's a lot of research going to areas of what's called, and I wrote it down on you. This is more recent. This one I just put together last night and today. NR is another compound that is sold by Chromadex. Chromadex is a company that is doing research on NAD. Their whole emphasis on NAD. It's a niacinamide D-ribose complex, and it comes from cow's milk. So they isolate it from cow's milk. And now they're using NR, and it has great ability to increase NAD. And Life Extension is selling it, so is Swanson, and so will be almost every single company in the United States once they find out what it does. But interesting enough, I was talking to Ryan, the head director in research for Chromadex, in NR, and I told him what I'm doing, and he's very excited. I told him to look at colostrum and look at breast milk. And they said that the highest level of NR of this molecule is found in breast milk. So you understand how important breast milk is for the child. Okay? So they're going to isolate this molecule from colostrum because it's double the potency and it's a lot less expensive. But meanwhile, niacinamide works wonderful. Another thing that I wrote down that's very important is in our research with Florida A&M, we have a lot of things. DCA is one of the best things to change the pyruvate lactate back to CO2. And DCA is phenomenal. I'm just going to tell you, it is phenomenal. If it's used with methylene blue, how many of you know about methylene blue? You're right. You know what it does, right? Methylene blue is going to be the most exciting area besides C60. Methylene blue has anti-aging mechanisms. It has anti-inflammatory mechanisms, antioxidant mechanisms, but it is one of the most potent anti-tumor mechanisms we know of. In combination with DCA, they work similar by redirecting the aerobic glycolysis back to oxidation of glucose, which is the normal way you want the pathway to work. So methylene blue is going to be another exciting area, and there's an article coming out by Ray Peat next month. Another area that we look at is vitamin K. K is very crucial for everything: mitochondria, bone density, cardiovascular function. Now, you can get it from K1. You know what K1 is, right? K1 is cheap, and it's literally the cheapest molecule out there if you buy K1. K2, K4 is very expensive because in order to make K4 and K2 work, you have to use 30 to 40 milligrams a day to get the effects. Where K1, 2 milligrams is all you need. It converts in the liver. And in the liver, it converts to K2, 4, and 7. That's how simple it is. Okay, another area we're looking at, I said restriction of amino acids. We have seen the studies on it, and it's validated by science. And these 3 amino acids, if we reduce the amounts of these 3 amino acids, tryptophan, methionine, cysteine, and cysteine, it will also give you the same results as caloric restriction diet by reducing the oxidative damage and glycation, and it also prevents aerobic glycolysis by reducing that. That's why, again, collagen is the only non-inflammatory protein on the planet today, because it also suppresses MMP9, which is what you've seen in the last slide. It also helps with bone and cartilage and connective tissue, which builds your immune system. Now, some of the, let me just share. You see this right here? In our recent screening of cancer by Florida A&M, we have discovered these compounds right now to be on the very top list as an anti-mitotic, anti-proliferating mechanism. And you cannot use just an anti-mitotic herb. You have to use both, anti-mitotic and anti-proliferating mechanisms. And frankincense, wild yam always comes out number 1 and 2 in every screening that they've done. And they've done over 200 screenings of cancer. Recently, we're screening for breast cancer, glioblastoma, small cell carcinoma, leukemia, and prostate. And we're doing methylene blue right now, and we're doing a few other things. So, and if you've seen some of this, what the key is to these compounds is knowing the right amount to take and how to take them, and what the extraction levels are and the whole plant levels are. So this is exciting. Let me share one more thing, EGCG. EGCG is coming out as individually one of the best anti-mitotics, anti-proliferating, and it will knock out Ebola virus. It stops the cell replication of any virus. That's how it works. It also does that with cancer. It stops the cell replication, okay? And there's a published paper that was just recently done on EGCG as having that kind of function. All right, there's a lot more I can talk to you about energy medicine, but we're going to do a whole section on it next year. And some exciting things on rebuilding.
Great, thank you. Thank you, Bernd. Clearly, we need to give you more time in the future.
Okay.
So, no time for questions. I'm sorry, we have to pack up and get out. But I'm sure he can answer one-on-one questions if you'd like to come up and ask. Thank you for attending tonight, and we'll see you next month.